Okay, in this problem, we're going to be trying to figure out what the linear speed of someone standing on the Earth is since the Earth rotates once every 24 hours. So first thing I'm going to do is I'm going to write down everything that the problem gives me. Now I know that the total rotation, the angular displacement, is going to be 2 pi radians, because that's one total revolution, and that's how many revolutions the Earth is going to make in one day, which means that the time it takes to do this is 24 hours. And what I'm looking for is how fast someone's going, the linear speed. So to do that, I'm going to have to find, first, since I've got angular things with theta and time, I want to figure out, hey, what is my angular speed here on the planet Earth? So the first thing we're going to do is we're going to figure out the angular speed. Now the angular speed works just like linear speed, in that linear speed was distance over time. But an angular is going to be our angular displacement or distance, which is theta, over time. So I can find my angular speed by putting theta over time, which is 2 pi radians, all over the time, which is 24 hours. Now I could divide those and I can get an answer, and that will be all well and good, but what I really want is radians per second, not radians per hour. So we're going to have to convert. So I'm going to have my 2 pi radians per 24 hours. And I know there's 1 hour with 60 minutes. And I know 1 minute has 60 seconds. And when I multiply all of that out, my units will cancel. My hours will go away, my minutes will go away, leaving me with radians per second, which is exactly what it is I'm looking for. And when I do that, I find out that my angular speed is very, very slow, which is 0.0000073 radians per second. So in terms of angular speed, we're not turning terribly fast. But when it comes to linear speed, what we can do now is we have to use our linear to angular conversion equation, which is omega equals velocity over the radius. And I know that since I'm trying to find velocity, I've got to multiply that r up to that left side, so I'm going to have omega r equals the velocity. So now I've got to plug in my numbers. I know that the radius of the Earth was given to be a very large number, which is 6,378,100 meters. So that'd be 6,378,100 meters is the radius of the Earth. Very, very big. The angular speed, which we just figured out, was 0.0000073 radians per second. Abbreviate to r over s just for the space. And when I plug all that into my calculator, I actually get a pretty large linear speed of 464 meters per second for my linear speed. That is how fast we are going right now on the surface of the Earth. So we are moving, even though we can't tell it.